In this video, we will talk about solving rational equations. There are 5 steps to solving rational equations, which are listed here. I won't read them out to you or go over them one by one, but we will go over them in detail as we do examples. So pause the video and please copy these down in your notes. Okay, our first example, we want to solve this following rational equation. First off, we know it's an equation because of the equal sign, and we know it's rational because of the fractions. So step 1, factor each denominator. 3x, x, and 15 are all factored already, so we can't really do anything more with those. Step 2, determine the lowest common denominator, LCD, of all denominators. So the LCD between 3 and 15 will be 15, and between x and x, it'll just be x. So 15 has to be the LCD because 3 and 15 both have to be factors of 15. In other words, they both have to be able to go into 15. So this LCD has to be at least as big as the biggest number. So the LCD here is 15x. Step 3, multiply both sides of the equation by the LCD. Now, the difference between a rational expression and a rational equation is that in an expression, we would take each of these fractions and rewrite them using a denominator of 15x. However, in an equation, we can clear the fraction, we can clear the denominator. So step 3 says multiply both sides of the equation by the LCD. So let me rewrite this. We have 1 over 3x plus 1 over x equals to 4 over 15. This is our rational equation. We know our LCD is 15x, so we will multiply the left side of the equation by 15x, and we will multiply the right side of the equation by 15x. So step 3, to clear the fraction, we will multiply both sides by the LCD. Now step 4, solve the resulting equation. So to solve the equation, we will first distribute the 15x to each term. So the first term will be 15x times 1 over 3x plus 15x times 1 over x equals to 4 over 15 times 15x. It's very important that you show all these steps because it'll prevent you from making a silly arithmetic mistake. Okay, now let's reduce. 3 goes into 15 5 times, and x just they cancel each other out. So 3 goes into 15 5 times, x and x divide to be 1. So all we're left with here is a 5. If you multiply 5 times 1, our first term will be 5. We have 15x divided by x, so the x and the x, these divide to be 1. We have 15 times 1, which will give us 15. On the right side, the 15 and 15 divide to be 1. They cross cancel. All we have left is 4 times x, which is 4x. Now let's add these. 5 plus 15 is 20 equals to 4x. If we divide both sides by 4, we get x equals to positive 5. Now the last step, check for extraneous solutions. Extraneous solutions are solutions that are obtained through the process of solving the equation that do not satisfy the original equation. Extraneous solutions occur when the solution leads to a zero denominator. So let's take x equals 5, plug it in. 3 times 5 is 15. X is 5, and then that's 15. As long as we don't get a zero denominator from our solution, we're okay. So when you plug in x equals 5 into the denominators, it does not give you a 0. Therefore, x equals 5 is not extraneous, and it is a valid solution. Let's look at the next example. We have 4 over 3 plus 7 over x minus 4 equals to x minus 1 over 3x minus 12. Let's go through each step. Step 1, factor each denominator. So 3 is factored, x minus 4 is factored, but we do have to factor the 3x minus 12. So I'll rewrite this as 4 over 3 plus 7 over x minus 4 equals to x minus 1 over 3 times the quantity, x minus 4, if you factor out the GCF, which is 3. Now the LCD consists of all the unique terms. So we have between 3 and 3, our LCD is just going to be 3. Then we have an x minus 4, so we have 3 times the quantity x minus 4. This 3 and this x minus 4 are not unique since they're part of the LCD. So the only unique terms are 3 and x minus 4. This is our LCD. Second step, our third step, once we have the LCD, is multiply both sides of the equation by the LCD. So over here, let's multiply the left side by 3 times the quantity x minus 4 and the right side by 3 times the quantity x minus 4. So let's go through and distribute all this. Now again, don't skip this step. It might be tempting, but don't skip it because it'll lead to better understanding of the problem, and also it'll avoid making any silly mistakes. Okay, so what do we have? We got 4 over 3 times 3 times the quantity x minus 4 plus 7 over x minus 4 times 3 times the quantity x minus 4. Remember, it distributes to both of these terms. On the right side, we have x minus 1. The 3x minus 12 in factored form is 3 times the quantity x minus 4 times 3 times the quantity x minus 4. Okay, let's cross cancel things. Here, the 3's cross cancel. We're left with 4 times the quantity x minus 4. Here, the x minus 4 cross cancel. We're left with 7 times 3. On the right side, 3 times x minus 4, 3 times x minus 4 cross cancel. We are left with x minus 1. Now let's solve the resulting equation. We got 4 times x, which is 4x. 4 times negative 4, that's negative 16. 7 times 3 is 21. That equals to x minus 1. Once we distribute, let's combine our like terms. We have 4x plus 5 equals to x minus 1. We will move all the variables to one side, all the numbers, the constants to the other side. So if we subtract x, we get 3x. Subtract 5, we get negative 6. And if we divide both sides by 3, then we would get x equals to negative 2 as our answer. Okay, now once we get x equals negative 2, we still have to make sure it's not extraneous. An extraneous solution leads to a 0 denominator. So let's plug it in. Negative 2 minus 4, the first denominator will be negative 6 if x was negative 2. The second denominator, 3 times negative 2 is negative 6. Negative 6 minus 12 is negative 18. X equals negative 2 does not give us a 0 denominator, which means this is the correct answer. Okay, next example. First, let's factor each denominator. We have 5 over 2 times the quantity t minus 1. Since there's a greatest common factor of 2, 8 does not have a denominator. On the right side, we have 2t over 3 times the quantity t minus 1. We factor out the 3, and we're left with t minus 1. The LCD, now 8 doesn't have a denominator, so I'm going to put a 1 there. The LCD is the LCD of all the denominators. So between 2 and 3, the LCD is going to be 6. It has to be a number that 2 and 3 can both go into. And t minus 1, that's the only other unique factor, because this t minus 1 will already be in the LCD once you include the t minus 1 from the first denominator. So our LCD is going to be 6 times the quantity t minus 1. Now let's take our equation, which is 5 over 2 times the quantity t minus 1 plus 8 over 1 equals 2t over 3 times the quantity t minus 1. Make sure we write these in factored form. We're going to multiply both sides by 6 times the quantity t minus 1. Okay, so let's distribute the 6 times t minus 1 to both sides before we cross cancel. We have 5 over 2 times the quantity t minus 1 times 6 times the quantity t minus 1 plus 8 over 1 times 6 times the quantity t minus 1 equals 2t over 3 times the quantity t minus 1 times 6 times the quantity t minus 1. Make sure you do the step where you distribute. Let's cross cancel. T minus 1, that divides to be 1. 2 goes into 6 3 times. We have 5 times 3, so our first term is 15. Here, well, nothing cross cancels, but we do multiply the 8 times 6 because they're both on the outside of the parentheses. So we would get 48 times the quantity t minus 1. On the right side, the t minus 1's cross cancel. 3 goes into 6 2 times, and 2t times 2 will be 4t. This is our resulting answer. Now we got to solve this equation. So first, let's distribute the 48. So this gives us 48t minus 48 equals to 4t. Then combine like terms. You got 15 minus 48, that's a negative 33, plus 48t equals to 4t. We have to get all the variables on one side. Since the negative 33 is the only constant here, let's move the 48t to the right. And what are we left with? On the left side, we have a negative 33. On the right side, we have a negative 44t. I'm running out of space, but as my last step, I will divide both sides by negative 44. If I do that, I'm left with t equals to negative 33 over negative 44. So negative over negative is positive. 33 over 44, you can divide these both by 11. 33 divided by 11 is 3. 44 divided by 11 is 4. And our answer is going to be 3 over 4. Let's make sure this does not give us a zero denominator. If you plug it in, you can see that you're not going to get a zero denominator. So this is a valid answer. Our last example we will do in class. So if you want, you can try this on your own, and we'll go over this in class.